Fine-tuning several layers in deep learning. A pre-trained model can be loaded and only a few layers can be trained. This approach works better when the given problem is very different from the images that the model is trained upon. Fine-tuning is a common practice in deep learning. This gives advantages when the dataset is small. The optimization also can be obtained faster. Training a deep network on a small dataset results in overfitting. This kind of overfitting can also be avoided using the fine-tuning procedure. The model trained on a bigger dataset should be also similar, as we are hoping that the activations and features are similar to the smaller dataset. You can start with the stored weights path as shown below. Load the Visual Geometry Group (VGG) model and set the initial layers to be non-trainable. The VGG model will be covered in detail in the following section. For now, consider VGG as a big deep learning model that works well on image data. Replace the fully connected layers with new trainable layers using the code given as follows. A small two-layer feed-forward network can be built on top of the VGG model with usually hidden units, activations, and dropout as follows. A small two-layer feed-forward network can be built on top of the VGG model with usually hidden units, activations, and dropout as follows. The top model has also to be loaded with weights that are already fully trained. The top model can then be added to the convolutional base. We can set the top 25 layers to be non-trainable up to the last convolution block so that the weights will not be updated. Only the rest of the layers will be up. Compile the model with the gradient descent optimizer at a slow learning rate with a magnitude of order of 4. We can combine the augmentation techniques that were covered earlier with shear, zoom, and flip. The generator can be added with flow from the directory with both the train and validation datasets. Now the model can be fine-tuned combined with data augmentation. This way of training gives a better accuracy than all the previous methods. The following is a guide for transfer learning. Depending on the data size, the number of layers to fine-tune can be determined. The less data there is, the lesser the number of layers to fine-tune. We have seen how to improve the accuracy of the model using transfer learning techniques.